Hello and welcome to the micro lecture on random forest. In this micro lecture you will learn what the structure and basic components of a decision tree and also a random forest are, as a random forest is only an ensemble method using multiple decision trees. You will understand how a random forest improves prediction accuracy, and you will be able to differentiate between a random forest and other methods, more specifically XGBoost and LightGBM. And you will be able to evaluate strengths and weaknesses of a random forest. Subsequently, the agenda of the micro lecture is the definition of decision trees, then followed by a definition of a random forest. Then we will talk about the structure of a random forest, the functionality of a random forest, and we will provide you with an application example. Then we will talk about the strengths and weaknesses and a comparison with other methods. So, what is a decision tree? Scientifically, it's a model that structures data hierarchically through conditions. Meaning, you basically you look in your data if they fulfill certain conditions, and based on if these conditions are met or not, you go through kind of a structure that asks you for these conditions and you end up with a result. So the structure is you have one root node, which is like the beginning, and every node contains a condition. And then you either fulfill it or not. So then you have the yes branches or the no branches, which leads us like branches are another part of the decision tree. And you have the decision node. So that's basically the result of a condition, so if it's fulfilled or not. And you have the leaves, which is like down at the bottom of the decision tree, which is your result. Very intuitive decision tree would be, do you want to know if an ice cream shop has high sales? Then you have to like go for, okay, is it over 20 degrees Celsius outside, yes or no? And then, is the sun shining, yes or no? And if you say yes to both, then it's probably a high sales day for the ice cream shop. That would be like a very, very simple decision tree. So basically the functionalities of a decision tree is to determine a root node, then to do the splitting of the data. You can also do recursive splitting and then the prediction or classification. And the advantages are that it's very intuitive and that no scaling is necessary. The disadvantages are that it easily tends to overfit on the data, that it's very unstable and has limited accuracy. And all those disadvantages lead us to why we need a random forest and not a simple decision tree. The random forest is a machine learning algorithm which was developed by Leo Breiman and Adele Cutler in 2001. Since then it's become very popular, and it is an ensemble learning algorithm which consists of a large number of decision trees. Therefore it's also called forest because it's made up of a lot of trees. And so it combines the results of individual decision trees and uses them to make a prediction slash classification. So each decision tree is trained on a subset of the data and provides an individual prediction or classification. And then the random forest then uses either a majority voting for classification or an averaging over the results if in case of a regression problem. And it's, as I said, very popular and often used in business and research. Here is an example of how a random forest would work. Just as a note beforehand, random forests are usually applied to big data, so to much larger data sets. That's just like for visualization or for explaining how it works. So here in the example, we have 5 features and 6 instances, and we have 4 random subsamples that are drawn from the dataset, which you can see on the right-hand side of the picture. So in the first subsample, you only consider the variables x0 and x1. In the second, x2 and x3. In the third, x2 and x4. And in the fourth, x1 and x3. And as you also see, you have different combinations of which instances are included in the subsets. And then, based on these 4 different subsets, 4 different decision trees are generated, which you see in the right lower corner of the picture. Also, the decision trees have different depth. So, for example, the second one is not as deep as the other ones. And then all the decision trees do a classification of either 0 or 1, and you have then that the first decision tree provides as a result 1, the second 0, and the third and fourth 1. So you have a majority vote, and then in this case the result would be a 1. And you also have out-of-bag data, which is abbreviated by OOB. So that are data points that are not used for training, and those are usually or sometimes are used to evaluate the model performance. Here is an overview about the strengths and weaknesses of a random forest. So it's usually quite accurate. So the swarm intelligence thing does work. And although in general machine learning models tend to overfit, random forests have the techniques to avoid overfitting through like the bootstrapping and bagging. And so it's robust against noise if you have some outliers, because these outliers won't be included in all the subsets, and therefore probably the trees that overfit on the outliers or that are deterred because of the outliers will be neglected in the majority vote. And also the random forest is very flexible, so it can be used both for classification and regression. The disadvantages or weaknesses of the random forest is that it has high memory requirements, so usually a lot of runtime, because it calculates numerous decision trees at the same time. And also it's not really interpretable, so there's a possibility to show important features, but like in a linear regression you can very clearly say which variable has which kind of influence. That is more difficult. And you also have higher computing requirements and a slow prediction time. Here is a comparison between the random forest and other methods, for example gradient boosting methods like XGBoost or LightGBM. So what the main difference is that with the random forest the trees are independent and that you train them parallel. With the gradient boosting methods the trees are dependent and that you train them sequentially, which makes them more precise, by the way. So in terms of robustness, the random forest is insensitive to noise, whereas the gradient boosting methods can be influenced by missing data. For the training time, because you can do it for the random forest in parallel, it's comparably fast. I know I just said before that it takes some time compared to like statistical methods, but compared with like the other gradient boosting machine learning methods is rather fast. And therefore also the XGBoost and LightGBM are rather slow because of this sequential training. And areas of application, usually yeah, all these methods are tested on certain problems and then it's seen which performs best. But yeah, you can also say that the random forest usually works better on a moderate data set, and that the XGBoost and LightGBM are used on high and complex data sets. So as I said, the random forest already is usually quite precise, whereas XGBoost and LightGBM tend to be more precise, whereas that always depends on the data and the problem. So I'd usually advise to test all of 3 algorithms and then see which performs better on a specific problem. Yeah, so that's the comparison with the other methods. Now you should be able to understand how a decision tree and, yeah, more specifically a random forest works. And you should understand how a random forest generates accurate predictions or classifications. You should know the strengths and weaknesses of a random forest compared to other methods, especially XGBoost and LightGBM. Thank you very much for listening.